I'm going to say that again for the recording. I do keep attendance because the university requires that I keep attendance. Your attendance does not count toward your grade. Make sure you sign in on that sign-in sheet that's going around. Pass this down to him, please. Ma'am, or Luke. Oh, wait, I gave you two, didn't I? There you go. Deja, good morning. Good morning. I guess I am going to start over again. There's a sign-in sheet going around. Everybody make sure that you sign in because I do keep attendance. The university requires it. It does not count towards your grade. I do not give participation grades. If you want a participation trophy, join Little League. If you want a trophy in this class, you've got to win, place, or show. Now, that sounds ominous and scary. The fact is, Deja will tell you I'm kind of a pushover. You're going to find that I will work with you as hard as I can to find every excuse I can to give you as many points as I can to get your grade as high as I can. But every point you get will be because you demonstrated that you learned something of the material in this class. All right? Let's go through the syllabus. And you know what? Before we do that, let's start with introductions. My name is, anybody want to take a stab at it before I tell you how it sounds? It looks like Hebert to some people. Actually, to most people, if I take away the acute, most people look at it and they think it says Herbert. They stick in a phantom R there between the E and the B. How many of you have ever read that thing on Facebook where they put a paragraph, they write a paragraph and all the words are jumbled up, but you can still read what it says fairly easily? Everybody seen that? That's because in English, as long as the first and last letter are correct, technically, it's the first and last letter of a syllable, but for most words, it just works out for the whole word. As long as the first and last letters are correct, your brain will sort the middle and make sense of what it's supposed to say. That's why my name it just destroys English speakers because it's French. And the first and last letters are both silent. Tony, front and center. There you go. First and last letters are both silent, which messes up everybody. It is pronounced a bear. Just trust me. Okay? We can't go through a proof. You're just going to have to take my word for it. I am Dr. Abear, and I hope that by the end of the semester you'll find out that I'm not as frightening as y'all think physics is. I hope you're going to find that's true of physics as well. So let's go around the class first. I'm going to tell you up front, I'm the world's worst with names. It will be the end of the semester before I've probably got most of your names down, and there will still be one or two of you that I don't. And I'm really working to try and fix that. But in the meantime, let's at least start off on the right foot and go around the room and find out who everybody is. Tell me your name and what your major is. Logan O'Connor, Engineering, Graphics. Garrett Wallace, Civil Engineering. I've got a cousin who did civil engineering. Spent a lifetime in the Navy building dams all over the world. Civil engineer. Navarro? What was your first name? Spell it. Saul, okay. I wasn't sure I was hearing it right. Tyler Crabtree, civil. Let me guess. All of y'all are engineering. Francisco Uvalde. You got competition. That's a fun name. Francisco Uvalde. Luke Holmes? Great. Welcome to physics. Boring name. You're gonna do fine in life. Say your name again. Chyandria. One word? Cool. Oh, we're going to have problems now. I don't know whose name I'm going to enjoy most. Kennedy Metcalf, pre-physical therapy.
Micah Britton.
Deja McClellan.
Okay, now I don't feel bad if you can't say my name. All right, let's go through the syllabus. Everybody's got their textbook, I take it. Grades, because I'm sure that's front and center in most everyone's mind. I've already told you I don't give participation grades. Every grade, every point I give you, and I will look for excuses to give you points. I will give partial credit on your homework. If you show me what you've done, I will look for every excuse to give you as many points as I can, but every one of them will be because you demonstrated that you learned something. There will be 14 homework assignments, one each week. Each one is worth 20 points. There will be 14 labs, one every week. And each lab will be worth 20 points. Now, do not miss the labs. Those are 20 easy points. That is as close as you're going to get to a participation grade in this class. Because basically, if you show up and you work and participate and you do the experiment, you will usually work in groups. But if you participate, you turn in the report, you get the 20 points. So you don't get graded on whether you got the right answer. You get graded on whether or not you did the work. On the homework, you've got to kind of actually get the right answer too. And then there will be 6 exams, each of which are worth 100 points. And that totals 1,160 possible points. Did someone say something? No? There is no guarantee, no hard and fast rule, but it generally works out that by the end of the semester, I will be giving you some kind of bonus work, probably a bonus exam. Good morning. This is physics. You're in the right class? Excellent. Make sure you sign in the sign-in sheet and introduce yourself, your name and field of study. I'm sorry. Health and Sciences? Excellent. Here's your syllabus. I'm Dr. Hebert. There's a story behind that, and one of your classmates can fill you all about it. So, 600 points for exams. By the end of the semester, I will probably be giving you a bonus exam. that will just give you some extra points to help get your grades up. Let's talk about the homework. The homework is due every week in class on the first class of the week, on Monday. Late work may be penalized. If you turn it in late, I may take off 10% of whatever your grade was for every week you turn it in late. And at the end of class on Monday, it becomes late. Okay. Deja and Tony can tell you, don't hold your breath for me to enforce that rule. Okay? I generally accept late work, and I'm here to try and give you as many points as I can. And so I'm not going to take them away because you turned in work late. That said, good morning. Megan Walker. What's your major? Engineering graphics. See, I told you after a whole semester I might remember your name. What was I saying? Late work. I'm not generally going to dock you for turning in your work late, but there's a give and take here. If I feel like, if at any point during the semester I feel like I'm being taken advantage of, that y'all are using my kindness as an excuse to procrastinate in this class, my kindness will come to an abrupt halt. So do not count on me letting you turn in your work as late as you want. Okay? My hard and fast rule is that if it is turned in late, you have no guarantee that I will ever grade it. And if I don't grade it, you don't get credit for it. So make it your business to turn your work in on time. About your homework and your exams, it is in your best interest, it is in your own self-interest to make sure that it is as easy for me to grade your work as you can possibly make it. So you do not earn bonus points for fitting one extra problem in on the same sheet of paper. Paper is cheap. Trees are a renewable resource. Use paper. Make sure that your work is neat, legible, and that I can follow what you did. Like I said, I am going to bend over backwards to give you as many points as I can justify, as I can come up with excuses for. But you got to work with me. So like I said, it's your self-interest to make sure your work is as neat as you can make it. And please don't try to squeeze everything in on one sheet, on one side of one sheet. Here's an abbreviation for you. NWNC. Can anyone tell me what that stands for? No work, no credit. Now, most of you are probably already aware, and if you aren't, you will no doubt discover before the end of the semester that most of the answers to the odd-numbered problems are in the back of the book. Okay? And it always happens, at the end of the semester, someone's trying to get that last piece of homework done that they want extra credit for. And so they just go to the back of the book and they just copy the answers to all the odd-numbered questions. You do that, this is what you can expect for your grade. If I see that there's nothing on your page but answers and they're only the odd-numbered problems, and you've just skipped all of the even-numbered problems, don't bother turning it in. You will not get credit for that. I want to see how you got the answer. Now, that said, if someone does turn in their homework and all they put down are the answers, as long as you did all of the problems, the odds and the evens, then if you got the answers right, I'll probably still give you credit for it. But if the answer is not right, if you missed a sign or you moved a decimal place, the answer is either right or wrong. But if you don't show me the work, there's nothing for me to judge to give you partial credit for. So, make it your business to show me what you do, why you do it, show your work, and I will work with you to give you as many points as we can come up with an excuse to give you. I think that's about everything. Anybody have any questions yet? Anybody have any thoughts, comments, questions? This is something I do want to impress upon you. It is very difficult for me to stand up here and look at all your faces and tell who's getting it and who's not, who understands and who doesn't, who is confused and who's not, and who's just bored. I will try to explain everything as well as I can, but I need you to participate in this process. I need you to come to class ready to discuss and ask questions and stop me and say, wait a minute, I don't understand what that means. Why did you do this? How did that happen? Okay? This week, you already have a homework assignment. It's on Canvas. They're all posted there. So you can tell each week what you've got to do, what material we're going to be covering. This week, we're going to be talking about measurements and units. Up until now, everybody here is, again, I asked this already before everybody showed up, but how many of you here have had calculus? Have you studied any calculus at all? Integral calculus? Just you, okay. Can you read this? Read it to me.
Integral from number complete
Dizzy.
what?
Dizzy. That's a Z. DZ. E to the 1/3. That's that's E to the 1/3, or it's the cube root of E. Can you read that as a limerick? That really is a limerick, if you read it correctly. The integral z squared dz from 1 to the cube root of 3 times the cosine of 3 pi over 9 is the log of the cube root of E. And it just so happens that it's also mathematically correct. If you do the arithmetic, if you do the calculus, it comes down to 1/3 equals 1/3. What's the point? The point of that is I want to impress upon each of you that mathematics is just a language. That's all it is. It's like English or Klingon or whatever you happen to study. It's the language that we use to describe the world around us as we observe it. And up until now, you've taken math classes and you've taken algebra and trig, and maybe one or two of you have taken some calculus, and you've learned how to do the arithmetic. You've learned how to do the math. Up until now, it's been the analog of you learning how to conjugate the verb, how to spell the words, how to construct a complete sentence. You know, where do you put a gerund phrase? How do you distinguish adverbs from adjectives? You've been learning the syntax and the rules, but you haven't applied the language. Now, in physics, you're moving into literature. Now we're going to look at how this language is used. How is it written? We're going to look at how it's used to describe things that we see and observe every day. And we're going to use mathematics to predict behavior, to describe and to understand what we see. I think it was Lord Kelvin. Don't quote me on that, or somebody Google it and confirm if I'm right, but I think it was Lord Kelvin who said that when we can describe something mathematically, that's when we truly understand it. That's where we're going. That's where we're going. That's what you're getting into now in this class. Everybody here has had algebra, right? How many of you, can y'all read this over here? This is a proof. I go step by step, beginning with the precept that A is equal to B. For example, 1/2 is equal to 2/4. And using that precept, I prove mathematically that 1 is equal to 2. Okay? What's the point? The point, once again, is to impress upon you that mathematics is just a language. Show of hands, how many of you have heard in fact, everybody help me out. Finish the sentence. Numbers don't lie is a lie. Okay? Numbers will lie. In fact, one of my other classes this semester is a statistics class. And what's the saying? There are 3 kinds of lies. There are small lies, there are big lies, and there are statistics. Well, the fact is, numbers may not lie, but then again, neither do words. Words mean what they mean. They don't lie, but the people using them do. I hope that it is intuitively obvious to each of you that this proof is a lie. But can any of you show me or tell me why it's a lie? Where did I slip in the deception? Say again? Where did I divide B by B? 2B equals B? Yeah, right above that. B plus B equals B. Yeah, I'm just saying B plus B is 2B. And I've already established that it's equal to B. 2B equals B. And then you just divide both sides by B to get 2 equals to 1. That's not the lie. That's not the deception. Anybody else? Say again? A plus B equals B. Why is that? How is that the deception? Because you are getting very close. Mm-hmm. No, I started off with the precept that A equals B. Now, does everybody see how I get from here to here? I just factored A squared minus B squared into A plus B times A minus B. And then here I factored out of B, and I end up with B times A minus B. How did I get from this line to that line? Not subtracted. I divided both sides by A minus B. Get it now? What is A minus B equal to? If A minus B equals 0, Up to this point, this proof is perfectly true. Because anything times 0 is equal to anything else times 0. Because anything times 0 is equal to 0. But mathematically, you should have learned that division by 0 is undefined. And when you studied calculus, you looked at the limit as a denominator goes to, as a denominator approaches 0. But you can never actually put the denominator all the way to 0 because this is the sort of thing that happens. Okay, that's enough time on this. But I hope that what I've impressed upon you is that mathematics can be used to lie. It can be used to write poetry. It can be elegant. It can be eloquent. It can be clumsy and awkward. But at the end of the day, it's just a language that we're now here to learn to speak and write. So, who can tell me anything about science? What is science? A lot of people these days, big fans of science, but who can tell me what it actually is? What is the scientific method? You have the scientific method is simply that you formulate a hypothesis. You test that hypothesis with an experiment. If the experiment confirms the hypothesis, then you have science. It literally means, the word science is literally the Latin word for knowledge. And the scientific method is the difference between what you know and what you just believe. How many of you have heard the phrase scientific consensus? Anybody? Show of hands. Well, the simple truth is if it's consensus, it ain't science. If it is science, if it is known, there's nothing to concede. It is demonstrated. It is proven. If it is not proven, it ain't science. One of my undergraduate professors said that in one of my first physics classes, he said, we're here to study that which we can measure. Beyond that is theology. That's what we're here to do. We're here to look at what we can measure, what we can quantify and describe mathematically and explain. And that's what you're going to be doing every week in lab. This week, tomorrow, you're going to be doing your first lab where we're going to look at pendulums. And we haven't had time to go through the theory of pendulum motion and how it works, but I'll give you the mathematics, and y'all will use it to empirically test and confirm. So, what can you tell me about measurements? Some of the engineering students. Every measurement needs a unit. Yeah, you've got units. What else is important about a measurement? Units and significant. Did I misspell that? I think I did. Digits. We take a ruler or a tape measure or a laser interferometer, and we measure the length of this room from that wall to that wall. we can never measure the exact distance. We just can't do it. We can only measure it to the accuracy or the precision of the instrument that we're using to measure it. If that's a tape measure, then that's probably going to be to within plus or minus a 32nd or a 64th of an inch, because tape measures are generally broken down into little fractions of inches. If we're using a laser interferometer, it might be plus or minus half a micron or half a millimeter. Depends on the instrument. If we say that we measured the length of this room and we found that it was 12.4 feet, what are we saying? We're saying that we know that the exact dimension of that room is greater than 12.35 feet and less than 12.45 feet. That it's somewhere between those two limits. And in this case, we have 3 significant digits that we've measured. You go around, you go in, you take multiple measurements, and then you start doing the arithmetic. Your answer can never have, your final result can never have more significant digits than whichever measurement went into that calculation with the least number of significant digits involved in the calculation. Did I just completely butcher that whole sentence? You collect 3 or 4 measurements. Each one of them has some number of significant digits. Whichever one has the least number of significant digits, that is the most significant digits your final answer can have. Okay, so now what you need to understand, you need to learn is how many significant digits are in a measurement. I said we might measure something to, let's say we measure something that's 4 microns. Point 0.000004 meters. 4 microns, or 4 millionths, is that right? Tenths, 100,000, 10,000ths, 100,000ths, millionths. 4 millionths of 1 meter long. How many significant digits are in that measurement? 7. Let's see, we've got 1, 2, 3, 4, 5, 6, 7. Nope. It has 1 significant digit. The 4. All of these zeros are not significant digits. They are placeholders. They're telling you where the decimal point is. This is a point of confusion for a great many people, and it's one of the very first things you need to learn. When you're doing and dealing with significant digits, if the only purpose of the 0 is to tell you where the decimal point is, it's not a significant digit. On the other hand, if you measure the length of the room to 12.40, now this 0 is a significant digit. Because this is telling you that the measurement is somewhere between 12.395 and 12.405. So, when you add an extra 0 to the end of a measurement, that is another significant digit. If all you're doing is pushing the decimal point further away, that is not increasing the number of significant digits. Does everybody understand that? How many of you have heard of scientific notation? Yeah. This is the great benefit, one of the great benefits of scientific notation, is that it makes more intuitive, it makes more plain how many significant digits you're working with. This looks to some like 7 significant digits, and it's not an unreasonable assumption to make. But if you write it instead as 4 times 10 to the minus 6 meters, now it becomes obvious that it's only 1 significant digit. But 4.0 times 10 to the minus 6, now you can tell that more readily looks like 2 significant digits. Any questions set yet so far? Have any of you actually been on Canvas yet and looked at the week 1 assignment? All right, well, now let's talk about units. What are some common units? Engineering students. Feet, meters, inches, watts, joules, newtons. Who can tell me what a slug is? Anybody? Well, they are little animals. There are systems of units. In this class, we're going to work with, I'm going to get back over here so everybody can see. We're going to work with SI units. SI stands for Système International, and if I wasn't afraid of misspelling it in front of you, I would write it out, but you can look it up. It's French for International System. It is the standard metric system. It's what we call the metric system in the U.S. There are 3 fundamental units that we're going to use. MKS. When you see it written down, you'll usually see it written in uppercase letters. Can someone tell me what the alternative to MKS is in the metric system, in the SI system? CGS, usually written in lowercase. What does MKS stand for? Somebody want to guess? I can tell you the units are of length, mass, and time. Meters, kilograms, and seconds. Those are the fundamental units of the MKS system. When we work with formulas and equations, you're going to need to make sure that all of your units line up, that they work, that they're all the same. If the formula was developed using MKS, meters, kilograms, and seconds, then you're going to need to make sure all of your variables, all of your terms that you're incorporating into this formula are in units of meters, in units of kilograms, in units of seconds. So if you get a problem and it says, and it tells you that you're dealing with 14 grams of whatever mass that you're dealing with, before you plug that number into a formula, make sure you know what the formula needs. Does it need kilograms or does it need grams? If it needs kilograms, convert those grams into kilograms. We're going to look at how to do those conversions. So you'll be able to do them. You won't need to rely on looking up conversion factors. What does CGS stand for? Centimeters, grams, and seconds. It's still length, mass, and time. But generally, chemists and biologists work with much smaller quantities of substances. They work with smaller measurements. And so they use CGS as their standard system of units. Doesn't really matter what you use as long as everything lies, as I say, collars and cuffs. As long as the curtains match the drapes, everything's good. Your formula will have been developed. Your equation is written using whatever units it uses. Make sure the numbers you plug into it use those units, or your answer will be wrong. What about the British system? Or SAE, which I don't know, I don't really remember what that stands for. I think it's something like Standard American Engineering Units or something. What's the fundamental unit of length in SAE? Feet. Or it could be inches. Or could be mils if you're a machinist. A mil is a thousandth of an inch. What is the fundamental unit of mass? No. Nope. This is a trick question. Everybody be careful. You're about to learn something new. Pounds is a measure of force, not mass. Say again? No? The standard unit of mass in the SAE system is the slug. That's why I asked you a while ago if anyone knew what a slug was. The equivalent of a kilogram or a gram in metric is a slug in American. A pound or an ounce is a unit of weight. It's a measurement of force. In the MKS system, that would be a Newton. Named for the scientist, not the town in Massachusetts, and not the delicious little fruit-filled candy bar. Newtons convert into pounds or ounces. Kilograms or grams convert into slugs. And of course, in both, time is measured in seconds. Don't know why they've never fixed the whole seconds thing. Because when you think about it, everything else in the metric system is all, base 10. It's 1 meter divided into decimeters, decimeters divided into centimeters, centimeters divided into millimeters, divided into microns or micrometers, nanometers. Kilograms divide into grams, into decigrams, into centigrams, milligrams. But seconds are still just seconds. And there's 60 seconds in a minute, and 60 minutes in an hour, and 24 hours in a day, 365 and a quarter days in a year. And they've never tried to resolve seconds down into, decimal tenths of anything. And I'm not really sure why. Because, how inconvenient is seconds and minutes and hours? But don't let anybody repeat me. Don't quote me on this because I don't want to give them any ideas. I like it just fine the way it is. We've only got a few more minutes left. I'm going to share a story with y'all to kind of try and drive some of this home. And I do want to tell you all to make sure to go ahead and start on your homework assignment. You can read the book, you can read the material for yourself, and I want to encourage you to read the material, read the chapter that we're going to be doing each week before you get here. If you read it before you come into class, you'll be better prepared to ask questions. You'll be better prepared to know what we're going to be learning and what we're going to be discussing and trying to figure out. And you'll be better able to participate in the class, in the interactions. And then I will be better able to tell who's learning, who's getting it, and what we need to go back and revisit and explain better. Start working on your homework assignment. And that too will get you prepared to start asking questions. I generally try to start every class with questions about homework. And as Tony and Deja will tell you, if you ask them, I will even, like a big old fat sucker, I will stand up here and work the homework problems with you. Basically giving you free points if it helps you learn. Okay? Don't think I'm going to spend the whole class going through working the homework for you so you can just copy it down. But if you come into class with questions about one that's particularly tricky, then So, how important is all this stuff? How many of y'all remember several years ago, NASA sent a probe to Mars? And it spent, 2 or 3 years getting there, a couple of bajillion dollars in hardware and manpower and time and labor and effort and resources. And they get all the way to Mars and they go to land the probe, and instead of setting down in a nice soft landing, it smashed into the surface of Mars at 25,000 miles an hour and basically turned this bajillion-dollar probe into a cloud of Martian dust. Does anybody remember when that happened several years ago? No? It did. And it was almost as bad as when NASA launched the Hubble, when they put up the Hubble Space Telescope and turned it on and looked at it and realized, oh no, we made it nearsighted. They had to scramble to come up with a way to fix the optics and go back and put in a contact lens. Well, it was almost that bad. Not quite. Well, in some ways it was worse because it was a total catastrophic loss of everything. Well, they immediately set about having their meetings looking into what happened, how did this happen, why did we crash this bajillion-dollar probe into the Martian surface. And it turned out that when they were doing all of their engineering, one team had been working in SAE units, a separate team had been working in metric units, and nobody noticed. And when they brought all of the work together, they didn't convert their units. And the net result was the probe was still doing 25,000 miles an hour when it got to the surface of the Martian planet. That was just one example of what happens if you don't make sure your units match. And some of you are going to make this mistake. Some of you are going to forget to convert your grams to kilograms before you plug them into the formula. And your answer is going to be off by 3 orders of magnitude, because there are 1,000 grams in every kilogram. We'll look at how to do unit conversions and unit analyses on Friday. And we'll probably look some more at significant digits. And hopefully some of you will have some questions about some of the homework that you've been working on by then. One more thing I want to tell y'all. On exams, most of the exams will be in-class exams. Some of them might be take-home, depending on how much time we have on the schedule. If I'm running out of class days and I need to cover more material, I might give you a take-home exam. Obviously, a take-home exam is an open book exam. You can use your computer, you can use whatever, and if you cheat and look and ask Google to solve your problem for you, make sure you write down all the whys and the how-fors of why Google gave you whatever answer it gave you. In class, the exams are not open book. You will need to have learned the material and know how to work the problems and work them under proctored conditions in class. What resources you will be allowed to use are your calculator, because I'm here to teach math, not arithmetic. Okay? But this is one thing I do want to emphasize to you. That calculator is a tool. It does not replace your brain. It can do arithmetic stupendously. Someone once said a computer is just a blithering idiot, but it blithers 1 billion times a second. Calculators will do the arithmetic. You still have to do the math. We're here to learn the math, not the arithmetic. Make sure you have your calculator and you can use it during your exam. You can also bring an index card, a standard size index card, and you can write all your formulas and everything, and you will, in fact, if you pay attention, you might even notice occasionally I will very subtly hint that something is probably important and should be on your index card. You can have your index card for the exam so you don't have to try and memorize formulas. I don't care if you memorize the formula. I want you to learn how to use the formula. So, put it on an index card. You'll have it during your exam. You can write on both sides of the index card. You can write as big or as little as you want on your standard index card. You can write on the edges of the index card if you want to. You may not split the index card into 2 halves and use the insides. You can use all of the outside of the index card and only the outside. One card. Anybody have any questions? Well, was this first class that painful? Come back Friday ready to add. Oh no, come back tomorrow for lab. Stop before y'all go. Who has lab at what time? There's 2 labs tomorrow. One's at 10:30 and 8:30. Show of hands, who's at 8:30? Who's at 10:30? Is there any way we can get everybody at one time, or does everyone have scheduling conflicts in the other hours? Seriously, I'm asking. No? Yeah, it's actually kind of evenly split, and yeah, it's going to make more work for me, but that's what I get paid for. So we're going to show up for your regularly scheduled lab tomorrow, and be ready on Friday with questions.